record. All right, so what are we talking about in this presentation? It's how to make good team goals based on the game. And then we're going to break down those goals into some concrete requirements. And then from those requirements, we're going to develop some design ideas. And then to wrap it all up, I'll be talking to you guys about how to present. We're talking to you guys about how to make this work as a thing for your team. All right, as a framing device for this presentation, we're going to be talking about building a robot that plays basketball. Basketball isn't too dissimilar to what y'all do as an FTC team. There was a game a few years ago where you basically played basketball, actually. And you might have also seen during the Olympics, Toyota made a robot that plays basketball that played during halftime, I think during the France-US game or US-France game. Anytime that you see a basketball emoji come up, there'll be an example related to this robot basketball problem. And anytime you see a robot face emoji, it'll be something more aligned towards FTC in particular. All right, so starting with goals. Goals are a super helpful thing for your team to have so that you can have direction in how you execute yourselves as a team. In particular, having a quote unquote smart goal is really helpful, such that where smart means what specific, measurable, achievable, realistic, time bound. And different folks will put different words to those letters, but I like this set. But what that means, specific is you can't, like if you have a vague goal, it's like how do you achieve a vague goal? It doesn't make sense. And so to make it more specific, it's helpful to have the goal be measurable. So instead of score a lot of points, which is you can say I want to score 50 points. It's like yes, that makes sense. Achievable, well, is it easy to score 50 points? Make goals that are easy, because then you achieve your goals. And if you achieve your goals, that feels good. And if you feel good, that's great, because there's not a lot of opportunities to feel good these days sometimes. Realistic is it's kind of the same vein as achievable. Will you be able to do that? For example, like if you want to set a goal for 2 weeks from now, but you've got an exam, maybe don't make it so ambitious, right? And then to go with that, time bound. Put a due date on every goal, just so you can't just keep putting it off, but you have to actually boom, 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 hit your goals. Now these goals should be made by your entire team, and all of your team should agree to it. So one member of your team shouldn't be deciding from on high, yes, this is our goal, follow me, mortals. No, it should be y'all have a discussion as a team to figure out what your goal should be. And then everybody should agree, that is a good goal. Don't make it like a majority rule thing, because then it's like, well, if you say 51% of the team needs to agree, well, what about the other 49%? So everybody's got to agree. The scope of your goals should be pretty narrow. So all the goals that I got here are narrow to how do you perform on the field. I highly recommend making a goal that is how do you perform on the field, as opposed to goals that are centered around we want to win matches or win awards. You can't control how you win matches or awards, but you can control how you do on the field, at least to an extent. So make your goals about something that you can control. How well you do in awards depends on the judges that you get and how much sleep they got the previous night, which you have no control over that. I don't have control over that. And then don't overconstrain yourself with your goals. So you read this basketball goal that I got here. Basketbot should score 1 2-point shot from a stationary position in practice with no other players on the court on 17 October 2021. All right, so that's pretty specific. It's measurable. You know, score 1 2-point shot. It's achievable. You know, that is the most simple, you know, basketball thing that you can do. It's realistic in that, like, well, if we're going to build a basketball robot, we're going to have to do this. Doesn't seem overly hard. You did similar things in FTC. And it's time bound. You know, we have a due date, 17 October 2021. But what it doesn't say is basketbot should score 1 bank shot or 1 swish or 1 triple double, or some specifying a particular kind of shot. Leave it up to a later stage where you decide what kind of a shot you're taking. Yeah, so goals. Now, it's hard to just say like, oh, we're going to score 1 point and build from there. So break it down into small pieces. We'll call the small pieces requirements. They are the specific steps you need to achieve your goal. When you're constructing these requirements, it's good to make them smart in the same sense as the goals. Small, simple, don't have big complex goals that you can't even wrap your head around. Make it, these requirements should be something that you can like assign to a single team member, hopefully, or maybe a couple, just so that you have a little redundancy. But let people on your team own these requirements. Then also make it quantifiable. Like, oh, you need to. Well, I guess we'll get to examples on the next slide. So I've restated the goal up here. So we're going to break this goal down into requirements. We need to score 1 2-point shot from a stationary position in practice with no other players on the court. You'll notice that most of that goal is trying to narrow down what we even have to try to do. So, like trying to make it so that there's not a lot that you need to design for. All right, so 1 2-point shot from a stationary position. We need to choose what that stationary position is. So first requirement, a single static position in the bounds of the court from which basketbot can easily shoot must be selected by 25 September 2021. All right, so it's very specific language, almost like lawyery, which is good. You don't want any ambiguity in what this can be interpreted as. So that you can hand this off to somebody who owns it and they can just go nuts. And as long as they're staying within bounds of the requirement, everybody will be happy. Specificity is key. When you're writing these, you need to be more specific than you think you need to. Leave no room for doubt. But yeah, you'll see we've set a pretty early requirement, pretty early due date, 25 September, which is 1 week from today. But that's because a lot of things will depend on what position we're shooting from. How strong are the actuators on the ball shooter, for example. What height will we be shooting from? So we could be shooting the basketball from the floor, or we could make a platform that goes high up. And that will affect how we shoot, how we aim, that sort of thing. So we need to decide that as well by 25 September 2021. Again, same reason why the early due date as for the position. Other things will depend on it, so it needs to be early. Basketbot must be able to be moved into position by 1 or more humans by 17 October 2021. You need to be able to move the robot to and fro. You drive out to the basketball cart, get the robot out of the trunk of your car. You need to be able to actually do that, right? You have to be considerate of that sort of thing. The ball shooter must propel the ball such that it enters the basket, which is 120 inches off the ground. That's the NBA standard, and some distance from basketball, depending on the selected position, by 17 October 2021. All right, and so this is sort of the core meaty part of the design is we need to come up with a way to shoot the ball. Yeah. So that's our set of requirements. And so we can build, we got our set of requirements. Now we like come up with like, how are we going to do all these things? Well, so let's go through it point by point by point. I said point. Before we go through it point by point by point, let's talk about how we come up with ideas. I would recommend starting by taking one requirement and developing that into one idea. You can take multiple requirements and turn it into one idea, but that's hard. That'll be substantially harder than one thing to one thing. But if you do that, maybe it'll be innovative in the sense that judges will care about it. And then, while you're coming up with idea, you need to, just have ideas. There's not really a way to, automate that or simplify it. Is just have an idea. So you can be inspired by, how is this a task that you would do? Basketball. Yeah, like I've gone and played basketball before. Maybe the robot can be inspired by how I play basketball. Or maybe maybe it's not me playing basketball, but me doing something similar where I'm throwing an object into a target, something like that. So imagine a person doing this task. How would the person do it? Can you emulate that as a robot? One interesting thing that I've seen that's FTC specific is that teams will play the game with people, where you set up the field and have, instead of robots on the field, you have your team members on the field and trying to play the game. It's a good way to learn the rules of the game, and then it's also it gets into people's mind, like how would you actually complete these tasks. I think some teams will add restrictions, like you have to play on your knees and with one arm behind your back, so that it's not so simple to be grabbing these wiffle balls and moving them across the field. Let's see, there's also a bunch of other really good sources for mechanical design inspirations. So this Thang 010146 YouTube channel, really excellent. They've got tons of animations of mechanical systems that you can just sort of nick for yourself, and they're, I don't know, I'll just watch it to relax because it's fun. These are pleasing animations. This Electro Boom channel is great for electrical engineering design, which maybe that's not so important for FTC, since y'all aren't allowed to do electrical engineering. But all the same, he'll have some stuff once in a while that'll be interesting or useful to y'all. And then robots.ieee.org has a bunch of robots that are made by professional roboticists that you can take inspiration from. One thing that I'll recommend is to not do is to really copy what every other team is doing for the particular season. Especially the past few years, I've been seeing teams that are they're just kind of doing what everybody else. They're building similar robots to what everybody else is building because they're sort of like a meta design, and that's I don't know. I find that boring from the perspective of a judge, because I'm looking at the same robots every time. I can't imagine it's horribly fun for the students because y'all aren't getting to express your creativity. You're just doing what everybody else is doing. I don't know. Maybe I'm micromanaging. And if I am, that's fine. So yeah, let's go through our requirements and develop actual designs. So first of all, we need to select a static position from which our robot will shoot. Pick a place that is, let's see, I'll just read it. We shall place the robot 24 inches in front of the backboard and centered along the court's width. This will leave room for us to get an arc for the shot, but is minimally distant to put the least strain on the ball shooter design. It also leaves open the option to go for either a swish or a bank shot. So yeah, what you got there is, it's very specific about what the proposed design is. It chooses a coordinate in space relative to the backboard and relative to the court. It justifies why that position was chosen. You have room to get an arc, and that it's got a small distance. And it also offers that this leaves room for many design options, and that you can aim for a swish or a bank shot. This does restrict us from going for like a layup or something like that. But maybe the designers that came up with this plan were like, well, layups are hard. You need mobility for that. Let's just try to go for the shooting. So the goal doesn't call for mobility. So why add the extra complexity? All right. We also need to establish how high the robot should be, how high the robot should be shooting from. Is it shooting from 7 feet in the air, or is it shooting from the ground? This is a salient choice. And here there are 2 design proposals. One is to use a utility cart, like you see on the middle right here. This isn't especially high up. I think on a previous slide, I restricted the height to 70 inches. So yeah, this isn't especially high up, which maybe is more strenuous on the ball shooter, but it's more, it's very simple to implement. You just pull out the cart. And it's also like, if you can't, if a couple feet of height makes such a difference, it'll be really hard to move the robot to a different position on the court. The requirements only say a single static position, but maybe you got in your mind like, oh, like what's the next goal going to be? I don't want to have to repeat a bunch of work. And then the other option, getting much higher up, is stacking milk crates, like on the bottom right, on top of each other. You can stack arbitrary number of those so high, they're very easy to store. And you can use them for things that aren't, immediately robots if you want to. Yeah, so stacking milk crates will get you very much higher, but maybe it's a little bit wobbly because it's stacking. But maybe you can mitigate that with like weights and tape and stuff. It's a design decision. And now the folks that came up with this design would bring this to the larger team and be like, we have 2 options. Both seem good to us. We want input from the larger team of what to pick. Totally cool to have your larger team pick between a couple of discrete options. All right, so the basketball must be able to be moved. So one thing with this moving requirement is that we're good to we need some kind of an outside restriction for what does it even mean to like be able to be moved? Well, so I found the NIOSH recommended weight limit, which is it's the output of an equation that's in this PDF that's linked here, that based on the geometry of the person lifting, that is like how tall you are, how long your arms are, as well as like the weight of the object that you're lifting and how high you're lifting it, and some other factors. You can calculate how heavy you can lift, how heavy the thing you can be that you lift. Excuse me. You can calculate how heavy the thing, what the greatest weight that you can lift given those parameters is. I guess you don't calculate it with the weight of the thing. You use it to calculate the weight of the thing that you can lift. Anyway, you put in a bunch of numbers into an equation to figure out, okay, we can have this thing weigh at most 27 pounds. This is assuming that we went with the crate design, which involves lifting fairly high up to what I think I said 66 inches is the height. The output of this requirement is the ball shooter must be 27 pounds or less. Yeah. See, and then the funnest thing is, how do you design the ball shooter? And this isn't an amazing design or anything. This is just a pet example. But perhaps you could have a spring or a piston and a spring. So like the piston goes back, the spring gets compressed, and then you release a latch, and then boom, you launch the basketball towards the basket. And so this design spec offers an initial velocity for the basketball and an angle from horizontal that the basketball should be shot at. For this particular idea, I just threw in arbitrary numbers here, but like you'd work out some math to figure out what this initial velocity and angle should be. And in particular, you could go to your physics teacher and ask about this problem. And this is the problem that these numbers are the solution to is actually a very common like physics 1 sort of a problem. Also, one of the design ideas is also just sort of an undeveloped, like, oh, maybe we can use a 4-bar linkage to shoot. I don't know. And while you shouldn't lean on these kinds of half-baked ideas, it could be fun to throw them in, especially if they're wacky. Wacky ideas are fun, just in that it's like, oh wow, that's fun to think about. And maybe they can lead you down paths that are interesting. All right, so I've talked at length about this sort of idea of taking a goal, breaking it down to requirements, and from these requirements, building that up into ideas for your robot. And from there, you can do concrete implementations with cutting metal. So how do you do that with your team? Like, how do you actually implement this this strategy? Well, so first thing, make it so that your goals are known. I talked earlier about you need to establish these goals with your team and make sure that there's unanimous consensus that the goal is good. Make sure everybody is hearing the goal. Like basically every time somebody's in doing robotics, they're hearing the goal. Repetition legitimizes. If you hear something a lot, you'll believe it over time. Go over progress on your goals at least once a week as a team. So just if your goal is, okay, we're gonna score 50 points at our next tournament during one of the matches. Well, how many points are you able to get during practice matches that you're just running by yourself? That's salient progress. Or maybe like, oh, hey guys, we made it so that we can score extra points through like this weird thing in the autonomous or something. Just like lots of updates on what's going on with the goals. Where are we? Go over progress on each of the requirements. So I mentioned earlier, you should be assigning people ownership of each of these requirements. Just have everybody report out what status of everything is. Where's everything at? You don't need to know necessarily the tiny minutia, but it is good for everybody to know the status of the project. See, documentation is key. Really, this idea of like developing goals and then requirements and then ideas. This is an exercise in documentation. So document your goals, document your requirements, and document your ideas. And then your goals and your requirements and your ideas, they might change over time, and explain how they're changing, why they're changing, and just like keep everything down on paper. This can be good for you. Just the act of writing it will make it easy for you to remember. It'll be, if anybody's got questions on why something is happening the way that it is, maybe they missed a meeting, or maybe they weren't paying attention to that there's lots of systems on an FTC robot. They don't know why something's happening the way it is on the arm or something. Having documentation facilitates that kind of communication where you can explain, oh yeah, here's why we're doing it this way. Like I said, ownership for each requirement should go to 1 to 3 people. Simple things, you can give that to 1 person. More complex things, 3. If you're finding you want more than 3 people, or even 3 people maybe, that task might be overly complex. So maybe find a way to break it down. And then if you are, like we said that goals should be achievable, when you make a goal, celebrate. Like, you get limited opportunities to, like enjoy things. So, when you get one, enjoy it, celebrate, get like a pizza or something, make everybody happy. Do not fail your goals. Instead, just extend the deadline. So if you miss a goal, and like you go to a tournament, and you don't execute on the thing you wanted to do, well, just extend the goal till the next thing. Maybe make the goal easier to achieve or something. Reflect on why you didn't succeed, and you reflect very carefully. And a lot of the times, I think you'll realize that that you'll be missing stuff because, oh, hey, so and so had a lot of homework, or they had an exam, or just like your cat died or something, right? Like there's a lot of reasons why you can fall behind on stuff. Don't kick yourself for it. Just dust yourself off and set a new goal. So yeah, that's all I've got prepared. Happy to open up the rest for questions and answers. So if you want to post in the chat, I've got that open, or you can like talk through your mic if you want to. Yeah. And if there's anything that you want me to go back to in the slides, I'm happy to reshare that. I know there's a few URLs that maybe you could want to take down. As well, the slides will be, I'll be sending the slides to Amanda to post wherever she posts that. The recording of this presentation as well will be, I think Amanda said that will be going on to the SoCal FTC YouTube channel. How are you guys feeling about this game for this year? I haven't actually watched the video yet. Woke up a little late this morning. Maybe applying these techniques to this game could be good fun. I know that documentation can be very, very helpful. I'm just going to put these first couple slides in the video so that folks can see it. Yeah, great. Might get into the video editor and tack those onto the beginning. Yeah, with this Thanga 101 YouTube channel, it's really great because it'll it's got these animations. And it's like, oh wow, like I don't even know how I would apply that, but I love that it just moves in a straight line there. Ooh, that's great. Of course, there's more like practical sorts of things like oh shoot, so we had one like telescoping a couple weeks ago. There, this one's great. I saw this, I was like, this is something the FTC teams would like. Of course, this is possibly difficult to manufacture, so not sure how appealing it actually is. Were there any parts that anybody would like to see the slides again? I know I might have talked a little bit fast through a couple of parts of it. Yeah, glad to help. I did quite enjoy this picture of the dude. It's like a diagram of like parameters while you're lifting, while twisting. So like you see he's like facing like in this direction with his feet and facing like this direction with his face. And it's like whole body's twisted, and that like affects how much you can lift safely. This picture is just very nice. One thing with this calculation that I did here below is all of the measurements are based on my measurements. Like a 44-inch vertical location is the height from the ground to my elbows while I'm lifting something. Of course, I'm pretty tall. So, if you might want to take measure, if you have like a lifting task for your team, you want to measure things for like, each person that might be lifting something on your team. And choose find what the minimum recommended lifting weight or weight limit is for like your entire team. As well as I mentioned a few times, like, oh, like you can do some calculating. You can do some calculating. Calculating can be a bit hard if you haven't, if you're not familiar with the equations already. Guess and check is always a viable option as long as you document your guessing and checking, and are honest about it. Like, oh yeah, we were not familiar with the equations, so we guessed and checked. Here's the table of all the things that we guessed and the results. And just be scientific about it. You don't always have to use an analytical method, though an analytical method will save you time if you can have one. Another thing is that when you're making your goals, when you're making your goals, I think it's good generally to name your robots. I don't know, it can give you a little bit of a personal connection to whatever you're working on, instead of it being sort of a cold abstract thing. It'd be very easy to write this the robot, but there's nothing to the robot. Whereas Isaac 10, that's like it means nothing to y'all, but for the folks that understand, which are some friends of mine, like Isaac 10 is like that's a very like meaningful name for a robot. Any questions on how to set goals? Yeah, glad to present. It's always a good time. Been doing these for first time I presented was like in 2013, 2014 in there. And been, except for 1 year, I think I've presented at kickoff every year since. One more minute. Any questions? One thing that came up in the last session was what do you do about people feeling bad that goals were missed? Because that definitely does not feel great if you miss a goal. And ultimately, I think it's good to just figure out what went wrong, and make sure that blame doesn't get set on a particular person. Um, y'all are in high school, so you got way too much homework and classes 8 hours a day and extracurriculars, and what the heck, you're doing all this during a pandemic. I couldn't even imagine. I couldn't do all that without a pandemic in the way. um, so contextualize missing a deadline in terms of why it wouldn't be reasonable to make the goal, as opposed to like some sort of a ridiculous individual failure. That doesn't happen. But that's all the time we got. Thank you so much for all of you coming. I hope you all have a great season. And now I need to stop recording.